Hello everyone, I'm Monika Bhushan and today we are starting lecture number 2 of Power Series Solution. In last class we had seen the series solution of Bessel differential equation, right? And we got that what is Bessel function. So Bessel function is nothing but J in X. We had seen in last class, right? Now in today's class we are going to derive the recurrence relations. So today's class we are going to derive first two recurrence relations, and in coming classes we will be deriving 3, 4 and then 5, 6. So what we are going to see that these two derivations, right? So the very first derivation is for d by dx of x raised to n j n x, that is equal to x raised to n j n minus 1 x. Okay, and the second recurrence relation is d by dx of x raised to minus n j n x equals minus x raised to minus n j n plus 1 x. So these two you can relate with each other, that only the difference here in the left hand side you are multiplying j n x with x raised to n and x raised to minus n respectively, right? What is j n x? J n x is only by Bessel function, correct? Jnx is Bessel function and we are multiplying x raised to n with that, and then we are finding the derivative of that. So we get something, we'll get x raised to n jn minus 1 x. Similarly, if we will multiply jnx with x raised to minus n, okay, and then we will find the derivative of it. So what we will be getting, if I am multiplying x raised to minus n with jnx, then the finally we will get the answer as negative of x raised to minus n, and then it will be jn plus 1 x. Okay, now we will be starting this derivation. So we know that what is my jnx, right? Actually we have to memorize this jnx. This is nothing but my Bessel function. This is called as special function also, and we know that jnx is sigma r, which is equal to 0 to infinity, that means the summation starts from 0 to infinity, minus 1 to the power r x by 2 to the power n plus 2r into 1 by gamma n plus r plus 1 into factorial r. Okay, so in last class only we understood that what are these things. So n is, so this is order of Bessel differential equation. Okay, so this n we come to know. R is something which is governing this summation from 0 to infinity you are going to put, and then x is the variable. Okay, so this complete form is called as Bessel function. Fine. Now suppose we have to derive it in our exam, how will understand that which all steps we have to keep on going. So first we will write down jnx, right? Jnx, since we have understood what is jnx, we will write down it. Now the question only says us, because if we are just focusing on this left hand side, so in left hand side we know that we have to multiply this complete jnx, we have to multiply with x raised to n first. Okay, because this is in the bracket, so we will be just multiplying it. So for that, what we are writing down, what is my x raised to n jnx? This is nothing, we will just make the difference in the power of x only. This is as it is, this summation r 0 to infinity minus 1 to the power r, this is as it is. This x raised to n, if I will multiply, that means what does it mean? This is x raised to n plus 2r, correct? N plus 2r, and this is divided by 2 raised to n plus 2r, correct? Because the bracket is for both, and I have to just multiply here x raised to n. The base is same, that means power will get added, so it will be x raised to 2n plus 2r, but denominator will be as it is, right? Because I am not going to make any changes in the power of 2. So this denominator is as it is, and the numerator just made it x raised to 2n plus 2r. And then finally the remaining things are as it is. This is 1 by gamma n plus r plus 1 factorial r. Okay. So till here we are done. Now next what I have to do, I have to find the derivative of this complete term, whatever I have got. That means I have to find the derivative here. Okay. So to find derivative, what I have to do? So for with respect to x, the constants are r, n, correct? So the constants are r and n. Fine. So what we will be writing down? So this we will just copy this sigma r 0 to infinity. This 0 written because just copying it, right? This is r equals 0 to infinity minus 1 to the power r. So this complete thing is constant. I'm just copying it, and I have to do the derivation of this with respect to, I have to find the derivative of it, this term with respect to x. I have to find the derivative of this term with respect to x. That means this is x raised to 2n plus 2r. If I am finding out d by dx of this term, so what I will get? 2n plus 2r will be written here, and then x to the power 2n plus 2r minus 1. Correct? So this is only what changes we have made here for the derivative. Because 1 by 2 raised to n plus 2r is constant with respect to x. This complete term is constant, and this is nothing but gamma n plus r plus 1 and then factorial r. Okay, but you will notice that something we have made some changes here, right? This is as it is, you can write down in this step also. The next step you can make this change. What does it mean? We know one formula, one property of gamma function. Even this property we had seen in last class also, right? What was that? That gamma n is nothing but n minus 1, gamma n minus 1. What does it mean? That if you are finding out gamma n, it will be nothing but the previous term, which is n minus 1, into gamma into gamma of previous term, n minus 1, gamma n minus 1. Okay, so same thing we are writing down here. What we are writing down? This gamma n plus r plus 1. We can say that this is nothing but n plus r plus 1. So this is something which will be saying that the previous term is nothing but n plus r. Correct? N plus r, and then again gamma n plus r. Fine. But why we are making these changes? Because you can see that in the numerator we have 2n plus 2r, or if I will take out this 2 common, it is nothing but n plus r, and then denominator also we can make it in terms of n plus r, so it will get cancelled, because we just want to simplify also terms. And in simplification, what we will be doing? So if suppose 2 is present, so suppose anywhere I'll have 2, I'll make the adjustment with 2 either in the numerator or in the denominator. Similarly, if I'll have n r, n plus r, so accordingly I will make the adjustment, right, in the numerator or in the denominator. So the same thing we are doing here. Okay, so next is what? So next what we are going to do? So here we have written down that 2 we have taken common, and this is n plus r, this is as it is, and then n plus r here, right? So this n plus r and this n plus r will get cancelled. To make it cancelled only, we had made these changes, right? Now we can see that 2 is present here also, 2 in the denominator also, right? So again we'll do some simplification. 2 will go down. If 2 will go down, that means what I'll write down here? N plus 2r minus 1, right? If this 2 will go down. So this is 2 raised to n plus 2r minus 1. Okay. And then here gamma n plus r. And then this term till here, everything is same. Correct. Now again we are doing something more also, right? Some changes again we are making. But why we are doing this change? So because we'll just see that what I have to prove. I cannot do anything, right? I'm doing it with some reason, and the reason is I have to write down this LHS into this form. The right hand side says us that write down this in the form of x raised to n, this j n minus 1x. Okay, so for that my job is to take out this x raised to n common, right? So can I take this x raised to n common? So here only I'll see that if it is your x raised to 2n plus 2r minus 1, so I can write down x raised to n into x raised to n plus 2r minus 1, right? Then only, because the base is same, so if it will be in the same term, so it will be what? Only x you will write down, it will be n plus 2r minus 1. So I separated out this x raised to n, right? So this much only I can, by looking at the answer what I have to bring, I will take out this x raised to n common. Okay, and what I'll do for this j n minus 1x. Okay, so here what we are going to discuss about this j n minus 1x, we know that this jn is this much, right? So this jn is what? One generalized term, right? If I want to know what is jn minus 1x, n is nothing but the order, right? This is nth order. This jn is the nth order of Bessel differential equation. This jn minus 1x is the Bessel function of n minus 1th order of Bessel differential equation, correct? So this, what I have to do, if jn is something like this, so if I want to know what is my jn minus 1, so in this general term, what I'll do, wherever I have n in my right hand side, I'll make n minus 1 accordingly, right? I'll make here also n minus 1, and everything is same because this is jn minus 1 only, so the r, x and all other things will be same. Similarly, suppose if you need to know that what is your n plus 1, that means jn plus 1. So for that, how you will come to know what is your jn plus 1? If you know what is your jn, nothing, will just write down, instead of n, you will be writing down this n plus 1 and then it will be your n plus 1, right? So this is only what we will be doing here, that I need to know that what is my jn minus 1. So to compare with jnx term, I've just written down here what is jnx, and then we will just compare this term with this term, right? Because what my goal is to write down this this right hand side in terms of jn minus 1x term. Okay, taking out this x raised to n outside, sigma 0 to infinity minus 1 to the power r. Okay, x raised to n plus 2r minus 1, 1 by 2 to the power n plus 2r minus 1, and then gamma n plus r factorial r. Okay, so this term I will now compare with this term, right? Now, what is my jnx? In my jnx, my the power of x is n plus 2r. Similarly, the power of 2 is n plus 2r. And here what we are seeing that this is power of x is n plus 2r minus 1, or you can write down here nothing but n minus 1 plus 2r. n minus 1 plus 2r. Similarly, the power of 2 is what? N minus 1 plus 2r. That means if it is my x by 2 to the power n plus 2r, this is for jnx. For jn minus 1x, it should be x by 2 to the power n minus 1 plus 2r. So this is also written here only, right? We don't have to make any further adjustment. This is done here only. Okay, now I should be having, if in my jnx it is your this is your gamma n plus r plus 1 and then factorial r. So factorial r will not get changed, this is okay. So we can write in this term also, this is nothing but instead of n I am writing down n minus 1, and then r plus 1 is present here, r plus 1, because n plus r, what I have done, I have just written down plus 1 minus 1. Okay, so for that we got that this form is nothing but jn minus 1 x form only. Okay, so this form is nothing but jn minus 1 x form only. So we are done with this proof that right hand side we have got x raised to n jn minus 1 x. Okay, so now we are done with, so we can say that we have proved it. Okay, now the second derivation. So in the second derivation, what we see that we have to get this d by dx of x raised to minus n. Jnx is nothing but minus x raised to minus n jn plus 1x, right? So this is my left hand side, and by now this is my right hand side, and by now we have the clear idea, right, that what all things we should do. Very first thing for the proofs is nothing but you need to know what is the formula, what is jnx, right? Because based on jnx only your derivation is there, right? So jnx is nothing but this is your sigma r, which is r 0 to infinity, right? R is governing this sigma, and then minus 1 to the power r x by 2 to the power n plus 2r 1 by gamma n plus r plus 1 and then factorial r. So this is jnx that I should be knowing that this is the formula. Now what I have to do, I'll go with that what they are asking in that form only. I need to multiply it with x raised to minus n. So I have multiplied it with x raised to minus n. That means what I have made changes here, only in terms of x, only the power of x will get changed, everything else will be same. So that means this sigma r to r, which is 0 to infinity minus 1 to the power r, even the denominator, which is 2 to the power n plus 2r, everything is same. This is again same, only the change is the power of x. That means initially the power of x was x raised to n plus 2r. I am going to multiply it with x raised to minus n. That means the base is same, so x plus 2r minus n. That means x raised to 2r. Okay, so till here I think there is no doubt. Now what I have to do, I'm going to take the derivative of this term. That means whatever I have to get, I have got, I need to take what is d by dx of it. That means derivative will be with respect to x. So sigma r, which is 0 to infinity minus 1 to the power r, is as it is same, because this is constant with respect to x. Now we see that this is x raised to 2r. So derivative of x raised to 2r will be how much? It is nothing but 2r into x raised to 2r minus 1. 2r into x raised to 2r minus 1. Okay, this 1 divided by 2 to the power n plus 2r. This is again constant. Even this term is also constant. We don't find any x is here. So we'll just copy it same way, right? Now, but we see that there is some changes we have made here. This part is okay. The gamma n plus r plus 1 is okay. Instead of factorial r, we are writing down r into factorial r minus 1. Why we are doing it? Because if I have found this derivative, I have got this 2 into r, right? 2 into r is present. So r is in the numerator also, r is in the denominator also. So I will just cancel it out, right? I want to just make it either them in the numerator or in the denominator. So r is present here, and the r is in the numerator and the denominator is factorial r, right? We know that factorial r is nothing but r into factorial r minus 1, correct? That means what? Factorial 6 is how much? 6 into factorial 5. That means 6 into factorial 6 minus 1. Similarly, factorial r is nothing but r into factorial r minus 1. So r into factorial r minus 1. Then this r will get cancelled. Okay, now what about this 2? 2 is present here also, 2 is here also. So 2 will get down and it will become n 2 to the power n plus 2r minus 1. Okay, so till here what we have done, whatever they had asked us in the left hand side, we have just done the same way, right? Till here we are done with this much term. Okay, now we have to see in the right hand side. That means what they want us, in which form I should be writing down this left hand side, because this much only I could have done by looking at the left hand side. Now I have to do some rearrangement so that I will get this right hand side. And what I need to have in the right hand side, I can see that the negative is there. Okay, negative, that means yes, I have minus 1 to the power r. So if I will take out, suppose if I take out minus 1, that is negative. So it will be what? Minus 1 to the power r minus 1 kind of thing. So these things can also be adjusted, right? Okay, now x raised to minus 1 is actually taken out from j n plus 1 x. Okay, so that means whatever I have got here, I can do here one thing, right? I can take out x raised to minus n easily. That means what I'll write down, instead of x raised to 2r minus 1, okay, I will write down what? I need to take out x raised to minus n. But I cannot see n here. So how I will take out x raised to minus n? For that, what I can do, x raised to 2r minus 1 can be written as x raised to 2r minus 1 plus n minus n. Correct? Because since I don't have n here, the power of x is not having n, so I will take out n. So for that, what I will write down? I have written down x raised to 2r minus 1 plus n minus n. Fine. So in that case, what I will do, if I want to take x raised to minus n out, that means further what we can write down here, x raised to 2r minus 1 plus n into x raised to minus n. Correct? So in that case, I will take out x raised to minus n and what will be remaining? X raised to 2r minus 1, x raised to 2r minus 1 plus n. Is that okay? Okay, now you can notice that after that what we can see, that if we have taken out this x raised to minus n, that is also okay. Here the summation actually starts from 1 to infinity. Why we have made these changes? Everything else we have discussed, but what we can notice here, that now the summation is from 1 till infinity, and the reason is, since we have cancelled out this r and this r also, that means my r is factorial r minus 1. That means my term present here is factorial r minus 1. Okay, so if factorial r minus 1 is there, and if my r is 0, that means this term will be what? Minus 1 factorial, correct? And minus 1 factorial is undefined. Okay, so we know that the negative factorial is undefined, so we cannot start our summation from 0 in this scenario. Okay, so in that case what we will be doing, I will just start my summation from 1. Okay, from 1 to infinity I'll do, so that it will become 1 minus 1, it will become 0. That is okay. But if I will start my summation from 1 to infinity, so it will not fulfill my Bessel function's property, right? Because the Bessel function, this j in x, should start with 0. The r, this variable name is just at random. We have taken r, a, b, c, d, anything you can take. But whatever we are taking, this governing body should start from 0 to infinity. And here we are saying that the summation will start from 1 to infinity. So what I have to do? If I have to convert it into my Bessel function, so I have to at any cost start the summation from 0 to infinity. So since we have written down r equals 1, or we can say that r minus 1 equals 0, correct? R minus 1 equals 0. So if I will start this summation from r minus 1 and then infinity, so it will be called as we are starting from 0 to infinity. Okay, but we have to consider this factorial property also. So what is the solution? We are going to substitute r minus 1 with some other variable. Say the other variable name is s. Okay, so what the solution here is, I am going to start this summation from some other variable which is say called as s, and then s will start from 0 to infinity. Okay, that means what I am saying here, I am saying that I am putting r minus 1 is s, so r is nothing but s plus 1. Okay, and in this case, what is my right hand side? In my right hand side, I am starting the summation from 0 to infinity, because my goal is to prove that this right hand side is in terms of j only, right? In terms of Bessel function only. Bessel function which is having order n plus 1, right? So I am starting my summation from 0 to infinity. So in that case, what changes I have to make? Wherever I had my r, I will be writing down in terms of s. That means r, and that means r is nothing but s plus 1, correct? So instead of r, I am going to write s plus 1, because my summation start from s variable. So everything I'll keep with respect to s. So it will be nothing but minus 1 to the power s plus 1. Similarly, here if I have my r, I will be writing down x to the power n plus, this is 2, and then this is nothing but s plus 1, and then minus 1. Similarly, here r will be nothing but 2 to the power n plus 2. Instead of r, I will be writing down s plus 1, then minus 1. Same case I will do here, n plus, this is nothing but s plus 1, and then plus 1. Similarly, r minus 1 is nothing but my s, correct? Factorial s. So the same thing we have done here. So same substitution we have made in this step, correct? Okay, now till here we have just done the changes, like the substitution from r to s. Now what I am doing, x raised to minus n I am taking out. Okay, I have to take out this minus also, because this is what right hand side I have to prove. So if I take out this minus, so minus 1 to the power s plus 1 is nothing but minus 1 into minus 1 to the power s. So if I write down minus outside, so here inside what will be? It will be nothing but minus 1 to the power s. So this term also got simplified. X raised to minus n has gone out. Okay. Now this is nothing but n plus 1 plus 2s. Correct. And the denominator also 2 power is also 2 to the power n plus 1 plus 2s. Okay. So we can write down x by 2 to the power n plus 1 plus 2s. Okay. And then this is 1 by, this is nothing but same thing, n plus 1 plus s plus 1 and then factorial s. Okay. Here also actually we have factorial s. Okay. We will be doing, we will just compare this term with this jnx term. Okay. So this jnx term says that this is nothing but r equals 0 to infinity minus 1 to the power r x by 2 to the power n plus 2r and then 1 by gamma n plus r plus 1 then factorial r. Okay. And this is jnx. Okay, so what I am writing down here, so this is your x by 2 to the power n plus 2r for jnx. So for jn plus 1x, it should be n plus 2s plus 1. Correct? This is nothing but n plus 2s plus 1. Okay. And instead of r, I am writing down s. R, s, p, q, anything you can write down, that doesn't matter, right? Here also we'll see that n plus 1 plus s plus 1. Again, I'll say that if you are writing r or s, it doesn't matter because the series starts from 0 to infinity. So r or s, they will be actually giving you the same impression. And then factorial s, factorial r. So this term is nothing but, if you will see that, we can write down this in the simplified form, that this is nothing but minus x raised to minus n and then j n plus 1 x. Correct? So this way we have proved the second recurrence relation also. So in the next lecture, we will be deriving recurrence relation 3 and 4. Okay, so if you find this class useful, please like and subscribe my channel. Thank you.